Is it a bird? Is it a plane? Of course not. It's our sun lighting up the sky. The sun is the star at the center of our solar system and is responsible for the Earth's climate and weather. With an average radius of 695,500 kilometers, around 960,000 Earths would fit inside. For this video, we will explore solar activity, specifically solar flares. What are they and what impact could they have on us? The first flare ever to be observed was also the most powerful on record. It occurred in 1859 and was reported by the British astronomers Richard Carrington and Roger Hodgson. The scientists observed the flare as the localized brightening of small areas within a group of sunspots. The events left a trace in Greenland's ice in the form of nitrates and beryllium-10, which allow its strength to be measured even today. First, a solar flare is an intense burst of radiation coming from the release of magnetic energy associated with sunspots. Sunspots are darker, cooler areas on the surface of the sun in a region called the photosphere. Flares occur when accelerated charged particles, mostly electrons, interact with plasma. Scientific research suggests that magnetic reconnection leads to the huge acceleration of charged particles. Magnetic reconnection is a physical process in highly conducting plasmas in which the magnetic topology is rearranged and magnetic energy is converted to kinetic, thermal energy, and importantly, particle acceleration. There are 3 stages to a solar flare. The precursor stage is first, and this is where the release of magnetic energy is triggered and only soft X-ray emission is detected. In the second, the impulsive stage, protons and electrons are accelerated to energies exceeding 1 mega-electronvolt. During this stage, radio waves, hard X-rays, and gamma rays are emitted. The final stage is the decay stage, where the gradual buildup and decay of X-rays can be detected. The duration of these stages can vary from a few seconds to as long as an hour. Flares are our solar system's largest explosive events. The amount of energy released by a flare can be equivalent to millions of 100 megaton hydrogen bombs exploding at the same time. But what are the effects? X-rays and UV radiation emitted by solar flares can cause long-lasting radiation storms in the Earth's ionosphere, the uppermost part of the planet's atmosphere, and trigger radio blackouts around the world. But just how dangerous can it be? Geomagnetic storms can interfere with technology including satellites, radio communications, and electric power grids. According to the National Academy of Sciences, a widespread power outage, if it lasts, could lead to the disruption of transportation, communication, banking, and finance system and government services, the breakdown of the distribution potable water owing to pump failure, and the loss of perishable foods and medications because of lack of refrigeration. Much is still unknown about the sun and space itself. Although solar flares are only a small part of solar activity, they can have a huge impact on planet Earth and our day-to-day lives. It is almost certain, however, that one day our limits of survival will be tested.